In this video, I want to go through a couple of example problems for using the 5-key approach with your Texas Instruments financial calculator. In our first problem, we're depositing $7,000 into the bank today and assuming that we earn a 6.5% rate of return or interest rate on the deposit. What we want to do is figure out how much we're going to have left after 15 years, assuming annual compounding. Set this up in your financial calculator. We're going to use the 5-key approach. Go ahead and turn the calculator on. And remember, the 5-key approach refers to these 5 time value of money keys along here. Now, the first thing we want to do is set up our N, number of years. Actually, N is number of periods, but since this is annual compounding, it's also the number of years. We have 15 years. So we take 15, put that into our N, and next up we have the interest rate. A 6.5% rate of return or interest rate, so we're going to plug that in. 6.5 into the interest rate. Next up we want the present value. The present value refers to how much we're starting with. We're starting with $7,000 that we're putting into the bank today. So 7,000 present value. Next up we have payment. Payment refers to an annuity. Annuities are equal periodic cash flows. We don't have any annuity in this problem, so we just want to zero that out. So 0 PMT. Now we've plugged in 4 values. We need to solve for the 5th, future value. Future value is what we're going to have at the end of the timeline, and that's what we're asking for here. How much will we have after 15 years have gone by? So once we've got all 4 of our values in, we can solve for future value. To do that, we first press compute CPT, and then what we're trying to solve, which in this case is future value, we get $18,002.89. So in this problem, our $7,000 will grow to a little over $18,000 during the course of 15 years. Our next problem, we're saving for retirement and want to save $4,000 per year at the end of each year for the next 25 years. Assuming you earn an 8% rate of return on your investments, how much will you have at the end of the 25 years? Now here, one of the key things you'll see is the per year. That tells us that we're dealing with an equal cash flow. It's over the entire 25 years, so this is an annuity. That $4,000 per year represents our annuity payment. So now we're going to start with 4,000. Put that into our PMT, payment. Now notice this time I didn't start over here with the N. It doesn't matter what order we put our values in, as long as we put in all the 4 factors that we know and solve for the 5th one. So I can put in payment first, I can put in interest rate first, I can put in N first. Doesn't matter which order I put these in, as long as I put in all 4 known values before I solve for the 5th one. Our annuity is going to last 25 years, so we'll do that next. 25 is our N, plug that in. Next up is our interest rate. We're going to earn an 8% rate of return. So 8 I/Y, put that in as our interest. And in this problem, note that we don't have a beginning value. We don't have any money into our account today. So we're going to zero out the present value. Tell the calculator that there is no present value to worry about. We've now put in our N, our interest per year, our present value, our payment. We're ready to solve for future value. How much will we have at the end of the 25 years? So compute FV, and we have $292,423.76. Our $100,000 that we put in, 25 years at $4,000 per year, has grown to nearly $300,000 over the course of the 25 years. In our last example, using the 5-key approach, now we're going to solve for an interest rate. You are offered $17,400 in 8 years in exchange for $9,500 today. So you are lending the $9,500 today in exchange for receiving $17,400 8 years from today. What we want to find out is what is the interest rate on this loan. Now, one thing to be careful of is if you plug these values into your calculator, $9,500 today as a present value, $17,400 as a future value, you're going to get an error when you solve for interest per year. That's because the way the calculator thinks, it wants to balance these things out. And if you put both of these in as positive, the calculator thinks you're getting $9,500 today and you're getting $17,400 in the future. Instead, you're actually giving up $9,500 today. You're giving that money away so that you can get $17,400 in the future. So we're going to have to make this $9,500 negative to reflect that it is a cash outflow and not money we're going to be receiving. So again, we go to our financial calculator, and let's start with our present value at $9,500. So put in the $9,500. Now we have to make that negative. To make it negative, we want to use this plus minus key. Don't use the negative or the subtract button, but it has to be the plus minus in order to convert it to a negative. You can see the negative sign show up there. That is our present value, what we're giving up today. In exchange, we're going to receive the $17,400 in the future. So $17,400 becomes our future value. That's positive because we're going to receive it. Notice there is no annuity stream in this problem. So we're going to zero out the PMT. And the loan is going to be for 8 years. So we want to make that our N, 8N. And now we've entered our number of periods, our present value, our payment, our future value. We can solve for our interest per year. Compute I/Y, and we get 7.86%. So the interest rate on this loan is 7.86%.